Alright guys, today's goal 6.3, parametric equations in motion. So we're going to be learning about parametric equations, parametric curves, eliminating the parameters, line and line segments, and simulating motion with a grapher. Okay, and why? These topics can be used to model the path of an object such as a baseball or a golf ball. Okay, so let's take a look. Parametric curve, parametric equations. The graph of an ordered pair x comma y, where x is f of t and y is g of t, are functions defined on an interval of t values, generally dealing with time, is a parametric curve. The equations of the parametric equations for the curve, the variable t is a parameter, and L is the parametric interval, and I is the parametric interval. Okay? So let's take a look at our first problem here. What you need to do, make a little table. You have t, x, y. See how it says negative 3 to 1? Plug in negative 3, negative 2, negative 1, 0, and 1. Okay? Plug those in for x and for y right up here. So if I plugged in negative 3, you'd get 9 minus 2. So you'd get x is 7. Y is negative 9. Plug in negative 2, you get x is 2, y is negative 6. Plug in negative 1, you get negative 1, negative 3, negative 2, 0. Plug in 1, you get negative 1, 3. So if we were to graph all these now, you'd get 7, negative 9, 2, negative 6, keep graphing them, so graph the others now. Get these points here. And there's our curve. Now the second one's asking you to graph negative 2 to 3, so we have to go back and we have to add a few more values here. So we just need to add 2 and 3. So if I calculate 2, you would get 2 comma 6, and if I calculate 3, you would get 7 comma 9. So if we graph those points now, so we still have these, and then you have to add 2, 6, and 7, 9. And this graph would be this. And if you look at the last one, it would be all of them. But notice there's no arrows because they're very specific intervals, okay? Alright, so let's look at the next problem here. It says, eliminate the parameter and identify the graph of the parametric. Okay, so I got to get rid of the t. So I got to solve one of these for t. Well, this one looks pretty easy. Subtract the 1. So I get x minus 1 equals t. Substitute this in right here. So y equals 2x minus 2. So it says identify, so this is a linear equation. Okay. So let's take a look at some other things before we move on to the next one now. Okay, so when you see cosine and sine, you have to think of a circle. Now remember, we know x squared plus y squared equals r squared. So if you think about that, x squared, y squared, well, what does x equal according to this? 3 cosine t plus 3 sine t squared. Okay? So what we have to do is square those both sides. So you get x squared plus y squared equals 9 cosine squared t plus 9 sine squared t. Factor out the 9. You get cosine squared t plus sine squared t. Well, but what does cosine squared plus sine squared equal? 1. So you get x squared plus y squared equals 9. So what is it? It's a circle with a radius of 3. Okay? Alright, let's keep going. Alright, it says a toy rocket ship is launched straight up from a cart. It's supposed to say that is 3 feet off the ground. Okay. Graph the toy's height against time. Okay, so we need to do a parametric equation here. So anytime you see toy's height against time, x equals t. Okay? Y equals, now remember, we're dealing with gravity, so it's negative 16 t squared. That's always there. Plus the velocity plus the original height. Okay? So now what you need to do, calculate these. Plug it in when x is equals 0.5, or sorry, when t equals 0.5 and when t equals 1.25. So plug those in and calculate, and that'll give you the height. See you guys tomorrow.